So today I'm trying to graph this function f of x, and to begin, I'm going to factor it. So now that we have both the factored and the original rational function, we can start finding the important and salient features for the graph. So first, the vertical asymptotes are when the bottom of the fraction is equal to 0. So that is when x equals 3 and x equals negative 3. The horizontal asymptote, if we look over here, is because as x gets closer and closer to infinity, x cubed, or infinity cubed, is so much larger than infinity squared that all of this stuff doesn't really matter, and we're just focusing on the 2x cubed and x cubed, and the ratio between that is 2 over 1. So the horizontal asymptote is y equals 2. The y-intercepts are when x equals 0, and that's negative 16 over 18, or 8/9. And x-intercepts are when y equals 0, so the top equals 0, because 0 divided by anything is 0, which is when x equals 2 and negative 2. So now we are ready to graph. Okay, so now that we have all our salient features down, we can start actually creating the shape of the graph. And first we know that there was a hole at negative 2, and usually you would plug negative 2 in to this function to see what the y-coordinate would be, but since we already know negative 2 is 0, is the x-intercept, we can just draw that right in. And now we can draw the basic structure of what this looks like from our points that we've been given, but we still need to find out what is going on outside of the asymptotes. And to do this, we can choose a number like 4 and negative 4 to see whether those points will be above or below the x-axis. Okay, so now that we have that f of negative 4 is 24/7 and f of 4 equals 24/7, we can graph those points. So 24/7 is about 3.5. So 4 and then 1, 2, 3.5, which is up here. So we know it looks something like that. We have to behave the asymptotes. And then this is also the same thing. So about 3.5. 1, 2, 3.5. And to behave the asymptotes, it would look about like that. So that is our final graph. And we're done.